between negative 2 and 1 from this function dx. And of course, the other one from 1 to 3 is from this function, 4x squared plus 2x minus 1 dx. All you have to do is calculate those and add them up. This is it. This is one of the properties of the definite integral. We can split the definite integral as long as the function is continuous, of course, we know that, and create two integrals and sum them up. Any questions here, please? Again, you can use the graphing calculator. If you want, I can show by hand. If not, we move on. Okay, let's leave it, and we can come back to those at the end after we finish all problems. The next problem is find an area. We're asked to find the area enclosed by these two. Good. So first, I have to graph those two. Find points of intersection, shade in the area, and then find the area. So first of all, I find the points of intersection when x squared equals 3x minus 2. Well, this is quadratic. I have to set it equal to 0. You can use the apps to find the solutions, but this is too easy. Is x minus 1 and x minus 2. So x equals 1 and x equals 2. Now I will graph. I know how to graph x squared. That's one of the easiest functions ever. It's this. So this is y equals x squared. The other one is a line. And I already know that the points of intersection are 1 and 2. So when x is 0, y is negative 2. And when y is 0, x is 2/3. So something like this. So the area is right here, between 1 and 2. That's all I need. So I know that the area is the integral from 1 to 2 from, don't forget that this is y equals 3x minus 2, from above minus below. Above minus below. The function above, so to show the graph better, is something like this. The function above is 3x minus 2. The function below is x squared. And again, you can determine the, you can find the definite integral using the graphing calculator. It's okay. Any questions on this? Again, we can come back and calculate these at the end after we go through all the problems. Now, we want to determine this. And this is an indefinite integral. We have to use a substitution. Can anyone give us the substitution? Wonderful. I tortured my students well enough. Great. Yes, that is the problem. That power, it's too complicated. Excellent. But we need to determine dy. So we have dy, very simple. I'm missing a number. A number I can always make up. Never x or anything else. So I can multiply by 3 and divide by 3. Who cares? I didn't change anything. So I have the 1/3 outside. The 3 and dx are in dy, so this is e to y dy. And that's it. But let's finish it. I want to finish this one. So This is the easiest function ever. Why? Because its derivative, its integral is the same. So I meant to say antiderivative better. Good. So now I have to go back to the original variable. It's a must in indefinite integrals. So then the final answer is 1/3 e to 3x minus 2 plus a constant c. That's it. Good. The next problem, let's take a look. Two integrals. We've done this in class. I selected them from the book. One is the indefinite and one is indefinite, the other one is definite. The same type of problem with the same pretty much substitution. Yes? No? Okay, very good. So let's take a look. So we have the integral from 0 to the square root of 7x. If you look at your notes, this was done in class. Good. Of course, we need the substitution, and that is
1 plus x squared.
of course. As long as I can make up the dy. So dy is without dy we cannot continue.
2x.
That's not the dy.
dx.
dx. Good. That is true. Good. So then I can make up a 2, no problem. I can multiply and divide by 2. Nobody cares. There's no change, no difference. But now dx and x and 2 are all in dy. Do not copy the limits of integration. 7 goes out, so I have a 7/2 in front. Do not copy the limits of integration, please. Okay, so the 2x and the dx are in dy. The cube root of this is the cube root of y. I'm going to write it as y to 1/3. Now I have to change the limits of integration. I cannot copy the limits of integration that correspond to x to an integral in y, because y is a function. So when x is 0, I get 1. When x is 7, when x is the square root of 7, I have 7 plus 1, which is 8. So then we have 7/2. Y to 1/3 plus 1 is y to 4/3 over 4/3 from 1 to 8. Yes, I have to flip. So I have 21 over 8. And when I plug in 8 here, I get 2 to the 4th, which is 16, minus 1. So 21 times 15 over 8. Any questions on this?
Yeah, I have one.
Yes.
When you are moving the 7 out from in front of x there, it's 2 times 7 times 1.
No.
Right?
7 can go outside from the very beginning. It's a constant.
Oh, okay. I see.
It's a constant.
So it was out there.
I will not multiply because I do not need anything else but 2x and dx. I cannot have anything else but 2x and dx. You can take this outside from the beginning.
Okay.
Because it's a factor. If it were 7 plus, no, we cannot do that. But it's a factor and we can move it already.
Okay.
I have another question, Professor.
Please.
It might be kind of a sillier question, but when you do problems, I know like there's definite integrals and indefinite integrals.
Yes.
When you use the substitution method, like when you plug in for y,
Yes.
what like for an example, like the total cost question where there was, you know, an integral from 45 to 0 or from 55 to 45, could you use the substitution method there too? Obviously it's easier, but I just want to make sure I'm not missing something there.
On x to 2/3, this is the simplest possible. You cannot do
Yeah.
anything.
Okay.
No.
So it's only when it's like super complex is when you
Exactly. The substitution rule is a technique that allows us to simplify the function so we can determine the integral. Yeah. If the substitution makes the integral more difficult, then it's not the right substitution, and it's first of all it's impossible. But anyway, but it means that it doesn't need a substitution. Very good question. Okay. Now this is the same, but this is an indefinite. We need to do it. Okay, very good. So let's do that. So here we have the integral from 5x, the fourth root of 1 minus x squared dx. Of course, the same substitution. So y equals 1 minus x squared. What about dy?
Same thing, 2x dx.
But negative this time, careful. Negative 2x dx. So now we take for the 5 outside. We don't care for it because it's a constant. But we need to multiply by negative 2 and divide by negative 2. So we have negative 5 halves in front. Then we have the negative 2, this, and this, and this. So they're all in dy. And this is y to 1/4. So y to 1/4 plus 1 is y to 5/4. So negative 5 halves. Y to 5/4 over 5/4 plus a constant c. Yes, we have to flip and simplify. I have negative 5 halves, 4 over 5. So that would be negative 2 in front. That's it. So this is negative 2. And then y to 5/4 is basically the fourth root. 1 minus x squared. You can keep it as y to 5/4, or you can change it into the fourth root. It's up to you. I highly recommend, to cut back on time, on the definite integrals, I will definitely use the calculator. Make sure that you enter the function correctly. Take your time on that, but in order to save time, of course, I will use the graphing calculator. You cannot on the definite integrals. But on the indefinite, with all the arithmetic and adding whatever and subtracting 1/2, and no, I would not. Okay? So use the graphing calculator so you don't run out of time. Okay, the next question is here. We're asked to find the consumer surplus and the producer surplus at the equilibrium point. Yes? Is that a yes? Very good. So we have d of x equals x minus 4 squared, and s of x equals x squared plus 2x plus 8. Well, first we have to find the equilibrium point. So let's do just that. x squared minus 8x plus 16 equals x squared plus 2x plus 8. X minus 4 to the second power has 3 terms. Please remember, 3 terms. The first term squared minus 2 times the first times the second plus the second term squared. And then we simplify. You can use the graphing calculator to find the equilibrium point. I don't mind, but this is too easy. It's negative 10x equals, is that the case? Minus 8. It's an ugly equilibrium point. I just want to make sure, did I copy this correctly? I copied it from, let's take a look. It's fine. It's 4 over 5. I just may have copied it incorrectly. So the equilibrium point, that was in 5.1. Okay, let me see the page number. It's easier for me to go to the page number in the book. 5.1. Where is it? 480. Yeah, I copied it correctly. X minus 4 squared sx. Oh yeah, okay, that's fine. It's correct. So one more time. Yep, okay. So 8, so it's 4 over 5. Fine. So the equilibrium point is 4/5, comma, and I have to plug it in. 4/5, so a d of 4/5. So 4/5 minus 4. Everything squared. What is that? So 16, what is this? Or 4 minus 20, so it's 16 squared divided by 25. So 4/5 minus 4. 20, so 16 squared, because it's positive anyway, it's squared. Okay, 16 squared over 25. So then the consumer surplus is this product. First of all, the integral from 0 to 4/5 from this function, x squared minus 8x plus 16 dx, minus this product, 4/5 times 16 squared over 25. And we'll get the number with the calculator. And the producer surplus is this product, 4/5, 16 squared over 25, minus 0 to 4/5 of this function, x squared plus 2x plus 8 dx. Again, I don't want you to, oh, nobody could see anything. Oh my goodness, sorry. So, first term squared minus 2 times the first times the second plus the second term squared. I set them equal to each other. I simplified x squared. I brought back a negative 2x, and I took back to the right a negative 16. Negative 16 plus 8 is negative 8. I divided negative 8 by negative 10. I simplified by 2, and I got 4/5. So now I have to go back anywhere, it doesn't matter, and determine the y-coordinate of the equilibrium point. So 4/5 minus 4. 5 times 4 is 20. 4 minus 20 is negative 16 over 5. So it has to be positive because I have to square it. So it's 16 squared over 25. So consumer surplus from 0 to 4/5 from the demand function minus the area, this product. The producer surplus is this product minus the integral from 0 to 4/5 from the other function, from the supply function, dx. And we can plug it in the graphing calculator and determine the numbers. Is this okay?